Hello, this is a project that Anahita Khodadadi and I did utilizing Formian and formex algebra together with the ParaGen method to explore structural forms of branching columns. And we looked at these branching columns supporting a grid shell. The columns had different height members branching at different positions, and also the spacing on the shell varied. And then they were all optimized for the weight and the pipe size. ParaGen, I've presented at several IASS conferences in the past, but it's basically a cyclic exploration process that combines a SQL database, and it pulls solutions out of that database, forms a population from which it then uses a genetic algorithm to breed a pair of them, and it sends that child solution then, in this case, to Formian. And Formian generates the geometry and passes that geometry on to STAAD.Pro, where it's analyzed, the pipes are sized, deflections are calculated, a series of different parameters are generated, and then all of that information is sent back up into the SQL database where it is stored and can be used to explore different options. Now, we're going to start with an explanation of the way Formian was used to generate the solutions, generate the geometry, and Anahita is the Formian expert. She's going to describe that to you, and then I'll pick up and look at how we use that throughout the cycle.
The topology of the branching column in this study is based on the Frey-Otto's hanging string model, where bending moment in structural components is minimized. In this model, the axial direction of each branch passes through the centroid of the area created by its upper level knots. For example, this image shows the axial direction of the trunk passes through the centroid of area created by its upper level knots. Or the axial direction of the first level of branches passes through the centroid of area created by upper level knots. The axial direction of the second level of branches is defined similarly. In this study, the parametric model of 4 branching columns and the single layer grid shell is created in Formian 2.0 using the concepts of formex algebra. The grid shell covers a 40 meter by 40 meter area. This is a similar area per column as in the Stuttgart airport. The branching columns in this project have 3 levels: the trunk, first level of branches, and second level of branches. The curved grid shell held by 4 sets of branching columns is at 12 meter above the ground and rises to 14 meter on the edge and 16 meter at the center of the grid. The configuration processing of branching columns begins with a parametric model of a flat grid shell, the centroid of a quarter of the grid, the knots where the branching columns touch the grid, and the relevant centroid of each set of 4 second level of branches. Then the flat grid shell and essential points are projected onto a curved surface by applying the circular barrel elevation function twice. The appropriate tilt angles of the trunk and branches are computed by using the equation of a straight line in 3 dimensions in a Cartesian coordinate system. After the centroids are projected onto a curved surface, the new z coordinates are changed, and the new coordinates are required for calculation of the tilt angle of the trunk and the first level of branches. Here, a give statement is executed to get those numeric values. In each generated tree structures, there are 16 points in the second level of the branches that touch the grid shell. The coordinates of these 16 points on the curved grid shell can be obtained by executing a give statement, but using the give function for several points will make the iterative process of form exploration extremely complicated, long, and more probable to become flawed. Another way of generating the second level of branches seems to be the application of the elevation function. However, this procedure displaces the joints and branches that are expected to pass through the centroid of area created by its upper level nodes. As you see, figure at the top right image shows this displacement. Thus, in this study, the only suitable method of defining the second level of branches was to apply a sharp novation function on the 16 points, connecting the first level of branches to the original flat grid shell and transforming them to the 16 corresponding points on the curved grid shell. Finally, the generated form in Formian is exported in DXF format to STAAD for structural analysis.
Okay, this gives us a quick overview of exploration with ParaGen. You're looking at different images of the solution set. You can sort these in any way and filter them. This is zooming in on a certain portion of the Pareto set. It limits the weight, and then it limits the modal frequency, and comes down to this set. You can click on any of those images and you get a detailed view, and if you click on some of those links at the bottom, you can pull up different files or download different files. ParaGen will also allow you to produce graphs. This is an actual graph of that Pareto set. You can click on any of the dots on the graph and it'll give you a detailed view, first a view at the side, and then if you click on that view, it'll give you the detailed information. In this problem, we kind of concentrated on these solutions, and this one in particular, 285, which was this. If you click on that, it'll give you the detailed information about that, and that's the one we eventually thought was one of the best ones. It had a little bit higher column base here, and good proportions and good performance. Okay, so that gives you an overview of form exploration, branching structures with ParaGen. Are there any questions? Thank you.